Hello everyone, good morning, good evening, welcome back. Welcome to Cloud and DevOps Batch 58. So before I start the session, I just want to give a quick recap on what's being covered in the previous session. Previous session, we discussed a very important topic called as okay, provisioners. Let's discuss about the provisioners. Okay, before I proceed, Harish, I could see your hand raised. Do you have any questions?
No, Manoj, I forgot to
Sorry?
know. No questions, Manoj. So I
Okay.
forgot to know.
Okay, no worries, no worries. We respect your uh, interest to ask the questions. That's the reason I was pushing myself to stop. Okay, all right. So let's get started. So with the infrastructure that we have built, okay, it's very simple. Now, if I want my infrastructure, it's very simple. All I do is, okay, so as a such, already I just started my workstation. Go here, copy the IP address. Okay, cd to Terraform, expense v5, do I get pull? Okay, now you just need to say apply. Okay, if you come here and if you say it's going to create your MySQL configuration management is going to be applied, and then backend, and then front end. Now, once it is completed with a single click of a button, we should be able to create the entire infrastructure with a single click. So what's next? So what's next? So let me try to understand what very important for. Okay, now I want to understand. Okay, something called as a backend. Okay, I'll ask you one question. How Terraform know um, that it okay? How Terraform is managing the registry? Okay, this is a very, very important thing that I want to talk, and the answer for it is backend. Okay, what is a backend? Okay, or a state, all these things we'll talk about it soon. But first, let's the infrastructure get created. Also, before I proceed further, I want to take a pause to take up any questions if anyone has. Let's say it's unreachable. I know the reason is because okay, it's always recommended you keep it as because right after the record is creating, it's it's waiting for some time. So cd to Terraform basics. Let's see what it happens. Okay, so let's try to keep your target for today. Today's target is goals for today. Goals. Okay, backend UI. Okay, these two are very important. Let's see. These provisioners are rerunning again because okay. So this is a very important interview question. If an interview, if they ask you why provisioners are creating, okay, if you want to make sure I want to run my provisioner all the time, irrespective whether there are changes in the infrastructure or not, how do you do? Or what is a trigger in Terraform? Okay, whenever you want to tell Terraform that this has to be executed on a specific event, okay, then you can use, okay, you can say, I want to run this provisioner whenever there is a change in the okay, IP address of this, or I want to run this whenever there is a change in the instance ID of the instance that was created. So it can do all these things. Okay, let's wait for it. Also, I have mentioned wait for 120 seconds because right after the DNS record is created, it's gonna wait for some time. Then only the record will be created. Okay, and it will be working. And if you see, though I have mentioned the TTL as 10 seconds, but sometimes when you delete a record and create a record, there are some times it's gonna take some time to activate. That's the reason I'm quite liberal about it. Okay, so let's wait for it. I'm expecting it should not trouble me. So let's see. Let's wait. 1 minute 30 seconds. I'm gonna wait for minutes. Okay, all right. Now see, it's very clear. So it started with MySQL. Okay, these three, 1 second, creation. It started with these three. Let's see how it works. My expectation is with a single click of a button, everything should work. Let's wait. Let's wait. It's gonna take 2 to 3 minutes of time. Let it come. Let's wait. Any questions, anyone, meanwhile? Perfect. It's almost getting completed. Let's wait. Now you might think, okay, why I should use Ansible playbook, right? Okay, you can also use Ansible pull mechanism. Okay, that is also something we'll see soon. But for now, let's get it started. So going forward, whenever any of the infrastructure provisioning is gonna take time, I'll just trigger them just before the session itself so that it will be easy. Okay, let's. Okay, prerequisite for the MySQL DB. I think we are very close. All right. Now, if you look at this, my entire infrastructure is created. And what I'm going to do is I'll try to SSH to this. Okay, so this is the IP address of it. I will just go ahead and try to see whether it is working or not. My expectation is it should work. So $48 gas. Perfect, it's working. Now EMI. Okay, I'm paying $400 for my EMI. Done. Insurance. So I'm able to add. So with a single click of a button, you're able to create everything. Okay. So yeah. So what's next? Now, if I try to run here one more time, what will happen? Let's see. Let's talk about that. That is an interesting point that I am interested. Okay, let's talk. If you rerun it, is it really creating the infrastructure one more time? How does it come to know whether it has to create the infrastructure all the time or not? How does it come to know? It says there are no changes to the infrastructure, right? How does it come to know? How does it come to know? How does it come to know? The answer is, okay. So this is a very important point everyone should know. How Terraform is not creating the resources again and again, again and again, again and again. For example, there is a classroom. Okay, there is a classroom. Let's assume there is a classroom. So in a classroom, if principal asks the class teacher, hey, how many students has come today? Or how many of them are leave today? So what is the first thing that he will do? Anyone? What is the first thing that he'll do? Anyone? Anyone? If a principal comes and asks the class teacher, how many students are present or how many students are absent today, what will be his answer? How does he come to know? What is the first thing that he'll go and check?
Checking the attendance sheet.
Sorry?
Attendance sheet.
Attendance register, right? That
Yes.
means your class teacher is maintaining a book or a registry that tells how many of them are present and how many of them are leave, right? So Terraform also, whenever you do a Terraform apply, it creates a file called as a terraform.tf state. It is very, very important. And that is the reason at any time you make some changes, it also creates a backup file. What is this file and what information does it has? Just see this. Can you see this? When you hit the terraform.tf state, which is a backup file, this contains the list of all the information that Terraform has created. That is the reason whenever you run an apply, Terraform is checking the state file, okay, with the code, okay, and making sure are there any changes or not. And it also compares the same with the real-time infrastructure to see are there any real changes or not. Based on that, it is going to become a conclude whether it is going to create or destroy. Okay, how Terraform is not creating the process again and again. Okay, how Terraform is not creating the resources again and again. So whenever you make a Terraform apply, what is happening in the backend? What is happening? Let's take your code. Okay, there is something. Okay, whatever the code that you have written, okay, it is going to compare that particular code with this state file. Okay, it is going to compare the same with the state file. Whenever you make a Terraform apply, whenever you make a Terraform apply, okay, whenever you make a Terraform apply, the code that you have written, okay, will be validated against the state file. Okay, then only it can tell you whether it has to create the infrastructure, whether it has to destroy the infrastructure. For example, you have created instance type is equal to T3 micro. That means T3 micro is going to be recorded on this. Okay, so the next time when you apply this, okay, the entire code is translated into what is the real infrastructure and it is going to be compared with the state file. Are there any changes or not? Okay, if there are no changes, then the next thing that it also does is it also going to, once this operation is completed, it also going to go, second, it's also going to go and check this. Okay, on the AWS, are there any real changes or not? If there are any changes, it's going to update the infrastructure. Okay, that is what it is going to do. Technically, it's a bidirectional. So let me. Okay. All right. So when you run the Terraform apply, okay, the code is going to be validated against the state file. Okay, and once the state file validation is completed, it is going to tell you whether are there any changes or not. And even before that, this is what happens. Okay, you run a Terraform plan. What exactly happens? Now your code is going to be validated against the state file. It checks whether are there any infrastructure changes or not. And the change in the infrastructure is called as the drift. Okay. So when Terraform has created 3 instances and you have deleted one instance manually, that means there is a drift. The code is saying to create 3 instances, and in the state file is also, it says there are 3 instances, and at the same time, it's not just like your code is going to be validated with the state file. And once the code validation with the state file is completed, it is also going to check against the AWS infrastructure. Okay, this is step number 1. And then this is step number 2. Okay, and if there are any changes either in the state file or in the code infrastructure, Terraform apply is going to make the changes on the top of this. Okay, when you make an apply, what is happening in the backend? So let's talk about it. When you make some changes in the backend, okay, when you do a Terraform apply, exact happen. Okay, your code your code will be validated against the state file, and the same will be validated, okay, the infra on AWS. Okay, if there are no changes, TF just refreshes and says nothing to update. Okay, if there are any deviations, okay, between what is there in the code versus what is there in the state file versus what we have, then those changes will be listed. Okay, will be listed as per what you have as per the code, which is the source of truth. Then those changes will be applied. Okay, it's very simple. Okay, for example, what I'm gonna do is I'll go here and I'll just try to change the tag. Okay, I'll just change this is equal to MariaDB. Okay, now observe what is going to happen. Okay, now you come here and try to make a Terraform plan. Now what it is going to do, since Terraform has created a state file which is going to capture what is being created by the Terraform, now your code is going to be validated against the state file. Validated against the state file. So your code and the state file are same to same. Step number 1. There are no changes. Next, it is going to go and check your code against the, okay, against the against the infrastructure that is created by the Terraform. Okay, first up is your code will be validated against the state file. There are no changes. Again, the state file is going to be validated against the step number one. When you do a Terraform plan or apply, your code is going to be validated against the state file. There are no changes. Let's assume. Then now the state file, okay, the state file, okay, where is that? So first your code is going to be one. Okay, the code is going to be validated against the state file. There are no changes. Okay, now the state file is going to be validated against the infrastructure that is deployed. And if there are no changes, it says nothing changes. Now I made some changes. Okay, I made some changes manually on the infrastructure. Now your code will be validated against the state file. Now, as per Terraform, there are no changes. That is step number one. What is step number two? Now the state file is going to be validated against just AWS infrastructure. Now the state file says tag of the MySQL is MySQL, but here the tag of the MySQL instance is MariaDB. There is a deviation. Now it immediately reports. Now when you try to make an apply, okay, so whatever is being there in the code will be applied. That is what it is happening. Okay, now you come here and if you try to apply, now since there are changes, it's going to be applied. If there are any changes in the state file versus your code or versus your infrastructure, the changes will be applied. Any questions on this? Any questions on this? Your code will be validated as the state file and the infra on AWS. If there are any changes, Terraform just refreshes and says nothing to do. If there are any deviations between what is there in state file code versus what is there in the state file versus what is there in the infrastructure, those changes will be listed as per the code, which is okay, which is a source of truth. Then those changes will be applied. Make sense? Clear? Now come here and try to do it. Clear? Any questions? Now I'll ask you one very important question. Why HashiCorp Terraform is creating two state files for every Terraform? Okay, why it is creating a backup file? What is the reason for that? Anyone? Okay. Now you understood the state file concept, right? Now what will happen if you lose the state file? Anyone? So for example, someone has accidentally deleted the state file and the state file also has the secrets. For example, you have written MySQL code. Okay, so here you have mentioned the password. Now your state file will also have that information. Now your state file also will have the information. Now my question is very simple. I'll go back to the classic example. The same teacher, if you come and if you say, okay, can you hear me, anyone? Can you hear me, anyone?
Yes, Manoj, audible. You are audible. Yes.
All right.
Yes.
Yeah. Thank you. All right. Now the state file is very important. Very, 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 very important. And the way how we organize is also very important. Now I'll ask you one question. I have asked you one question. What will happen if you lose the state file? Again, going back to the same classroom example, again in the same classroom, okay, the attendance is been recorded on the top of the attendance register so that if the principal or the administrator comes and asks the class teacher who is been attending from last 1 week or who has opted for how many number of leaves in the last 1 week, now the teacher will go and try to look at the register and then he's going to report it back, right? Now I'll ask you the same question. If the teacher loses the register, or if some funny kid in the class has destroyed the register, or he burned the register, now what will happen? Now if the principal comes and asks, can he say how many of them are present and how many of them are not present? Can he say?
No.
No, right? Can he say or not? How many of you say the teacher can still say? Anyone? Okay. Terraform lose track of everything. And technically, it's a mess then. Okay. So it will not work. And if you look at this, you're doing a Terraform apply from your computer, right? So let's say so right now this is created on the top of your Linux machine. Okay, state file is stored on the top of the Linux machine. So for example, there are 3 members who are on the team. Okay, there are 3 members who are on the team. So one of the engineer is Mike, and then there is Steve. Okay, Steve's computer, and this is Chris. And all of them had created the infrastructure on their AWS account. Okay. Now Mike has created the infrastructure. Okay, let's assume he created 3 servers. Let's say they created 3 servers. Okay, so they created 4 servers. Done. He did a Terraform apply, and it has created the infrastructure. Now the same code. Okay, so assume the state file is locally available. Okay, terraform.tf state. Now, if Steve tries to rerun the code one more time, okay, if Mike runs to run the Terraform apply one more time or Terraform plan one more time, so Mike will see a result saying that there are no changes to the infrastructure. Okay, if Steve tries to apply the same code one more time from his workstation, what will happen? Anyone? Anyone who is going to answer? I can say that they are very much well versed with the Terraform, and they're well versed practiced with what's been covered in the Terraform so far. Anyone? What will happen if Steve tries to run the same code one more time?
In that case, the code will not be validated with a state file. It will check with direct AWS infra. It will go for validation for direct AWS infra.
And then what will happen?
So it will check that the infra is exist. In that case, it will not overwrite, I think.
No. How in the first case, how come it will even check? So Steve doesn't have the state file, right? So first,
Yes.
when you do a code apply, what will happen? First, it checks what is being there in the code versus what is there in the state file. If state file itself is not there, then Terraform thinks, oh, there is no state file. That means that he is asking me to create the infrastructure. So it goes to the account and create the infrastructure. Agree? Make sense? What is the
Yes.
first step?
Yes.
Okay, your code will be validated against the state file and the infra on the AWS. If the first step, it is not or, it's and. So first step itself is failed. So what it will think, oh, since there is no state file I can see, that means this guy is asking me to create the infrastructure as per what is there in the code. Then it straight away goes and creates 4 more instances, which is a blunder. Agree or not? Agree? So if you are the single person in the team, it might or might not make sense. But if you are in a team, will it work? Will it make sense? Absolutely not, right? So when you're working in teams, this is not how it should work. Okay. So state, when you are dealing with teams, okay, you should organize them in such a way that where everyone should access the same state file. Okay. So this is very important. Okay. So since the state file is quite important, and we need to make sure we never lose it. Okay. So storing and organizing state file should be a strategy. Okay. Ensure it's never ensure state file is never stored locally. Ensure the entire team should refer the state file locally. Okay. Ensure no two team members should run the Terraform apply at a time. Even if they run, only one apply should be executed. Other should be prompted with a message saying it's locked. Okay. So this is very important. Okay. So storing and organizing the state file should have a well-defined strategy. Okay. So in Git, if there are some changes, you know what are the changes, right? Also ensure version control is enabled for the state file. Okay, that means even if the state file is corrupted, or even if someone deletes the state file, or if you want to go back 2 steps back, you can also do it at the state file. Okay, so the place where you store. Okay. And the place where you store your Terraform state file is referred as a backend. Okay, based on the cloud provider, HashiCorp supports well-defined. Okay, so excuse me. All right, let's get started. So come here. So a backend defines where Terraform stores the state file. Exactly what I said. Terraform uses persistent stored data. Again, Terraform offers premium, which is also called as the enterprise edition of Terraform, which is also called as the TFE. If you go with Terraform Enterprise Edition, you don't have to care about storing and organizing Terraform. Terraform is going to maintain that on the top of their own cloud. Okay. But 80 to 95% of the organizations go with open source edition of Terraform. Okay, because if you hire a skilled engineer, they can take care of everything. Okay, and what are the backends that are available? So local backend is nothing but okay, where your code is stored locally on your laptop or where you are running the code, which is a very bad thing. Next thing is remote backend. So the remote backend is unique among all the Terraform backends because it can store both state snapshots okay, along with the current state. Okay, but And along with the state, okay, these are the command: Terraform apply, Terraform console, Terraform destroy, Terraform format, which we used. Okay, Terraform import is something. If someone creates the infrastructure manually, they can also import it. Okay, you know, Terraform input, Terraform output, Terraform plan, Terraform providers is something, you know, Terraform state list. Okay, if you want to see the list of state files that are available, Terraform state list. It also shows you the list of infrastructure that is provided by it. For example, I just did a Terraform state list, right? So these are the list of resources that are created by the Terraform, which came to know by listing it. Okay, and if you look at this Route 53 main, okay, it is created, security it's created, these many modules of instances it created, Route 53 records it has created. Terraform state list is also something you can use. And taint is like, if you want to tell Terraform there are no changes in the infrastructure, but I want to destroy it. I want to destroy it. You can do that. So you can say, just say Terraform taint. Okay, that means this in, okay, I'm sorry. This, if you say this, okay, so there is another way. Okay, for example, Terraform taint resource name. What will happen is, even though there are no changes in the infrastructure, Terraform marks that particular object as damaged. When you make a Terraform apply, it's going to destroy that infrastructure. Okay, and Terraform untaint is like, okay, if something is tainted, you can remove it. Okay, the damage can be removed. So Terraform validate, Terraform version is also something we have seen. Terraform version. Okay, so the current version of Terraform that I have installed is 1.9.5. And workspace. Okay, workspace is also a concept. It is a way of organizing your state files in multiple folders. Like if you create a development environment, dev.tf state. Okay, so workspace is technically like a folder for multiple environments, organizing it in a multiple way. But again, this workspace is a very old way of dealing the versions of state file. I really don't want to use it because it's a very legacy way, but I have my own style of dealing and organizing the state, which I'm going to use. Okay, again, workspace has their own challenges. Okay, and if you are on Google Cloud, okay, so it offers something called as a Terraform's cloud storage bucket. It's just like a Google Drive. So what is Google Drive? We use Google Drive. It's just like an object level storage where we can store files like IMGs, JPGs, MP4s, any data of your choice, right? So if you want to store such kind of data in your organization, you use something called as GCS. Likewise, if you are on AWS, there is a service called as S3. S3 stands for simple secure storage. Assume it like a hardware drive, okay, for your computer. You don't want to store anything locally. What you're doing, you are connecting a external hard drive and you're storing everything on the top of the hard drive and you're keeping it safe. Even if you lose your computer, you still have the data, right? So likewise, AWS has a very unique service. Just a sec. All right. So AWS has a service called as S3. S3 stands for Simple Secure Storage, where we can use it, where we can tell Terraform to organize the state. Okay, this is a very important thing. So a lot of companies uses S3. Okay, let's try to write it as well. From here, why it is not working? Okay, all right. So AWS S3. This is a simple secure storage. Okay. My service on AWS to store almost infinite amount of storage, object level storage. Okay, we just need to pay based on the service, based on the storage you use. Okay. So for example, each and every company will have, so for example, let's take, whenever you apply for an application, okay, you submit your proofs for a bank, right? Like your Aadhaar card and PAN card. So they're gonna take the scan copy and they generate the PNG files and they're going to store it somewhere. So likewise, if the bank called as HDFC Bank is storing, is is opening 1 million accounts per day. So in a year, you have 360 million accounts, 360 records, 360 million records, 3.63 crore records, where even if the account is active or even if the account is not active, each and every bank has to save their customer data for the next 10 years. So if they keep things locally on the data center, it's going to cost them the lot because they need to maintain the storage array and everything, right? And there are high chances if they lose the data center, they lose the customer data. Or each and every company will have a backup solution, and where they have a use case of storing the backup for almost 1 year or 5 years or 8 years as per the company's policy. So if you want to keep these data on the top of AWS, AWS is a secure solution, okay? Both for storing the data and hosting websites. Okay, if you heard about on AWS a data breach has happened, okay, this customer has lost this amount of data, this particular amount of data, that is because of this AWS S3. This is the backbone of AWS. And earlier, when you create any AWS S3 bucket is a placeholder to host your data. So by default, it is going to be public. So people used to access this data. Okay, now they mitigated. Okay, so again, just like how you have a hard drive, HDD hard drive, SSD hard drive, likewise, there are multiple types of storages that are offered on AWS. So we would like to store our state on the top of this AWS S3. Okay, let's try to talk about that. Okay, so AWS S3 is a cloud object storage with industry-leading scalability, availability, security, and performance. Okay, so this is what it is. Use cases, backup and restore data, and again it has a lot of use cases and all the images, lot of things, lot of companies saves the data on the top of the information. Okay, what kind of data that you can store? Analytics data, log files, replication data, videos, pictures, backup, archivals, anything you can use. Okay, technically all you just need to say is you just need to use it. And as a part of the free tier, Amazon offers 5 GB of free tier as a part of the free tier. Okay, so let's try to go ahead and try to consume the service, and let's try to learn the options while dealing it. Okay, I selected S3, or you can also type this S3 here. S3 is a simple secure storage, and the shortcut for it is S. Now I have these many buckets, okay, for various purposes, and the name of the bucket should be unique across the world. Okay, so name of the bucket. What is a bucket? Bucket is just like, see, in your Google Drive, you create a folder, right? Which is also called as a workspace. Likewise, in your AWS account, bucket is a placeholder. Just assume it like a folder. Okay, but bucket is a workspace. You can consider it. Create a bucket. And what is the purpose of it? It's a general purpose that you want to create. Okay, it's a general purpose that you want to create, or what is your stand? You need to mention. Okay. And again, this is a directory, is a brand new option. That's 1 or 2 months back it came up. Recommended for low latency use cases. These buckets uses only S3 Express 1 storage class. What is storage class? Storage class is a type of storage. And based on this, billing will be. Okay. This defines how fast can you retrieve the stored data. Okay, so guys, I'll ask you one question. Has anyone requested for a bank statement for last 5 years? Anyone? 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 Has anyone in this class has requested your bank statement in the last 3 years or 5 years or 8 years or 10 years? Anyone? Mahindra, Vikram, Shrideep, Shailaja, Rachit, Monica, Girisha, Arun, David, Ambit. Anyone? Anyone? Anyone?
Yes, Manoj.
Okay. How much time it took when you requested for a 5-year statement?
They took a week from me.
1 week. If you request for a mini statement, like 1 month or 6 months, what will happen? How
I'll get it right away. I'll get
immediately?
it right away.
What is
Yeah.
the difference between it?
Uh, it is like a short form of data. I mean,
Do you
whatever
really
is
think bank is really running some query to give you that much amount of data which took 1 week of time?
maybe they maybe yeah they're running the query.
No, that's not true. Let me tell you one thing.
Okay.
Okay. So there is a concept called as a storage class. Okay. That defines, I'll talk about it, but hold there. Okay. The name of the bucket. The name of the bucket should be unique. Okay. It's not just to your account, it should be globally unique. So B58, B57, Terraform state. Okay. This should be unique across the world. And ACLs disabled, it should be disabled by default. And block public access. By default, it was not true in the past. Now you need to block it. Okay, if you block it, no one can access it, the data that is available. Versioning of the bucket. So what is this meant by versioning? So in Git, by default, it's going to capture everything in the top of the version. That means every time you make some changes, it is going to capture those changes and it's going to tell, oh, these are the changes that you made, right? Likewise, every time you make some changes on your code, the state file will be updated and each and every change should be captured and I want a version of it. So that even if someone deletes it or if something goes bad, I can still go back to the previous version. So always enable this. Next, encryption. Okay, by default, Amazon enables everything with AWS encryption with their own keys. But if you want to go with your own encryption, you can also go by supplying your own encryption keys and all. But okay, in my case, I have the keys. I can choose the keys of my choice. Okay, but I am not interested at this point of time. I just go with okay, I just go with AWS offer. That means whatever you save on AWS S3 is going to be encrypted by default. Okay, using the keys. So everything is going to be encrypted at rest. That means even if someone tries to hack the AWS storage device, still they cannot read the plain text data. Okay, the data is going to be encrypted. Okay, that's it. In the advanced settings, you have an option called as object level lock. Okay, which I don't want to talk at this point of time. So let's create the data bucket. Okay, so in Google, they call it as a drive, Google Drive, right? Drive is a word. Likewise, bucket is a word in AWS. Okay, now come here. If you come here, if you look at the properties, there is something called as storage class. Okay, what is that? Let's talk about it. Okay, where is storage class? Yeah, lifecycle rules. Okay, if you come here, create a lifecycle rule. Okay, you can select where the data has to be stored. For example, here, properties, bucket versioning, storage class. Yeah, intelligent tiering archive option. Okay, here configuration. So what does this mean? Okay, so here there are some where it's not coming. Okay, 1 second. AWS S3 storage class. Okay, so it offers huge varieties of storage classes. Okay, so AWS S3 standard. Okay, so whenever the data that you are organizing is quite frequent, that that data is going to be stored on the standard class. Okay, and for example, you can mention I want my customer data when someone tries to store an object. Okay, and it has to be there in the standard class for the next 3 months. And after 30 months, after 3 months or 6 months, I want this, okay, storage class of this particular information has to be stored to, for example, Glacier. Okay, so where the time, see here, if you store any object in this S3 storage standard class, you can retrieve the object. If you want to read the object, you can read it immediately. But here, the retrieval class is retrieval time is very high because here the type of storage that you use is very old. So whenever you don't use some legacy objects, typically companies will move these objects to the Glacier type. Okay, where the objects are going to be archived. That's the reason when you place a request, it's going to take time because the storage, it is going to be it is going to be compressed, and to uncompress it, they're going to do it once in a while. That's the reason bank, Rachit, Vikram, when you mentioned my bank has taken 1 week of time to grant me when I requested the statement of 5 years of old. That means based on the type of storage, the retrieval time, and how many zones the data is going to be stored would be varying. That's where there is a concept called as a life cycle policies. Where is the life cycle policies? Management. So you have something called as a life cycle rules. So here you can create a life cycle rule, and what you can mention is, okay, limit the scope of this rule using one or more filters, or apply. I want this rule to be applied to all the objects. Okay, what is the rule that I'm creating? Move the, okay, expire the current version of the objects. Okay, that means expire the current version of the objects for version enabled objects. Okay, for example, every time you are making some changes on the state file, that means the same state file with the different versions, the same 5 MB file is going to be created 100 times, right? Every time there is a file with 10 lines. In the first line, they changed A to B, and in the second line, they changed B to C, and in the third time, they changed C to D. So like that, if they're making keep on changes, it's going to create multiple copies of the same version, right? With the different versions, right? Which eventually increases the storage cost. So you're not interested about keeping 1000 versions continuously. You're only interested of keeping 10 versions, or you're only interested to keep the versions for 1 month or 3 months. Okay, because I do not want to keep 1000 versions of a file, which doesn't make sense. So I want to expire current number of versions. Okay, expire the current version of objects. Okay, days after the object creation, you can mention if a version is created, I want to delete it automatically. Okay, this is one rule that I would like to apply. B57, delete expiring objects. So maybe you can mention it as a 90 days. There is one life cycle policy that you are creating, or maybe 90 days, done. Now you can also create few more life cycle policies. Okay, so I would like to create one more life cycle policy. And the life cycle policy is I want to apply this to all the objects. And what is the policy? So delete, okay, permanently, okay, next delete. Expire the current version of the objects, that is done. Move the non-concurrent version of objects between the storage objects. Move the current version of the storage objects between the storage classes. This is what banks typically do. Okay, there are a lot of varieties of storage classes. Right now we are using standard 1A. Okay, once the object is created, okay, right now it is going to be standard all the time. By default, it is standard. Okay, what is standard? So standard is S3 standard offers high durability, availability, and it helps you retrieving the object quite frequently. And the availability is 99.99% availability. That means at any point of time in a day, okay, uptime dot is, if someone says my object is 99.99% available, that means in a month it cannot be down for more than, okay, 4 minutes. Okay, so every time you 1 line increases, the availability increases, again the cost also increases. Okay, but again I have to pay a lot. But if you go with standard 1A, so they are offering only 99.9% availability. Okay, but the retrieval cost will be little less. Okay, this is more suitable only for the data that is accessed very less frequently, but requires rapid access when needed. I mean, you're saying Amazon, I'm not going to use it much, but whenever I want, I need to access it quick. Okay, so you can also create a rule saying that after 30 days, I just want to move this, and you also want to add one more thing. Okay, so storage class transition from this to this, and again after 30 days, I want this to be moved to here, and after 60 days, I want to move to the intelligent tiering. When you go to intelligent tiering, what is happening? Maybe intelligent tiering. So Glacier would be better. So S3 Glacier costs, okay, because it's going to take a lot of time. So the data sets are for 7 to 10 years for longer to meet the regulatory compliance, where you have an option where you want to keep objects for compliance purpose for 7 to 8 years. Okay, but if you look at this, this is the lowest storage class and supports long-term retention and preservation of the data that has to be accessed once or twice a year. You know that you're never going to access this information, but I might use once or twice a year. Okay, it is designed for customers, particularly those in a highly regulated industry like financial, where data needs to be accessed once in a while. Okay, and again, if you see this archival data is very accessed and very low cost. And if you look at this, retrieval time is 12 hours. So Vikram, now you understood when you raised a request with the bank for to access the last 5 years of data, how much time it took? 7 years, so 5 days. Now, if you see this, if your request, if your data, if your bank has stored the data on AWS Glacier, it would have took 12 hours of time. Like this, they might be using something else. That means if you want to read an object that is stored in the S3 bucket that has a storage class of deep archive Glacier, it's going to take 12 hours of time to read the data back. All right. Now I want to go with S3 deep Glacier. Okay, S3 deep Glacier. Okay, if the object is greater than 120 days, I just want to move it into this. Okay, so if you create a rule, what happens? You need to acknowledge. Okay, now once an object is created and if the version is greater than 30 days, it is going to delete that. And if any of the object, okay, if any of the object is greater than 120 days of old, now it's going to move the object to the Glacier. Okay, this is just to save the cost, but I'm not interested about all that. Okay, so typically in organizations you do it, but I'm not interested about this, and this bucket is meant for the purpose of storing bucket, so lifecycle policies doesn't make sense here. Okay, but if you are accessing, if you are storing any sort of banks compliance requirements and all these things, then it comes up into picture. Any questions on this? But I highly request you to read this information. Read this more. It is theory. I don't want to spend more. Assignment. Okay. Now I want to tell my Terraform. Okay. I want to tell my Terraform, store this. Okay. I want to tell Terraform, store this. How can I do that? And again, be mindful when choosing the bucket name. Okay. Name also matters because, okay, actually there is a funny incident. It backs to April 2024. A user, okay, funny. A user created a bucket and the bucket was empty. And he was billed $1,200. Who is interested to know the answer? A user created a bucket and the bucket was empty. He left it, but he was billed $1,200 by Amazon. Okay, so let me ask internet user choosing the wrong AWS bucket name, massive bill. Yeah, maybe this article. Yeah, so user be aware, choosing the wrong bucket name can lead to a massive bill. Okay, so what happened was someone has created a bucket. Okay, someone has created a bucket, and after he has created the bucket, what happened was there is a tweet, by the way. Yeah, AWS needs to stop charging for 4xx requests to S3 bucket immediately. Okay, in GitHub, here are 63,000 references to US East-1 buckets alone. Okay, if you want to know about this, read this article. Okay, so a person has created a bucket with a name, okay, whose name is something XYZ. There is an open source project in GitHub called as okay, there is an open source project in GitHub. They created a bucket, they created an open source project, and they, instead of mentioning their bucket name, there is a typo mistake, and that led to the bucket created by another engineer with an empty bucket. And what this GitHub project is keep on doing, this GitHub project is keep on looking into that bucket. Though that bucket is private, okay, it's continuously hitting that because of the some webhooks concept. It is continuously hitting and telling that there is no object. Okay, continuously hitting and saying that no object cannot be accessible. Like that, since the bucket is continuously being accessed, this guy got $1,200 bill. Okay, so that's the reason you should be very mindful when selecting the name. Okay, so maybe how can I explain that is, oh, this is B58, right? Why did I create 57? Okay, let me create one more. You should keep something unique, okay? ACL's disable block, bucket version has to be enabled. Done, advanced settings. That's it. Okay, now you created a bucket and management, access points. How do you access this bucket? Okay, so this bucket, no one can create the same bucket with this particular name. Okay, so maybe what I can do is properties. Yes. I'll show you something interesting. Where is that? No objects. Management. Maybe I'll just say, I'll just upload an object. Destination details. Okay. Permissions. Properties. Okay. What I'll be doing is I'll just upload an object. Okay, add a file. Add a file. I just uploaded an object. Okay, this is an object, right? Now, this is my S3 bucket, right? Or maybe I can say, why should I expose my bucket? So let me try to delete this, okay? Maybe I can say, AWS sample S3 bucket, ADMs, Adams Learning, something like that. There is a bucket just for learning. I want to show you one important thing. With the link address. Okay, maybe I can also do one thing. What is the name of my bucket? The name of my bucket is this, right? Now let me try to access this. What is the output that I would get? Curl. Okay, this is HTTPS colon. This is the name of my bucket. Okay, name of my bucket and colon S3 dot. And you need to mention this. It's AP South 1, right? Or AP South 1 or US East 1. US hyphen East hyphen 1. Okay. Dot AP s3.east1.amazon.com. So what is the response that you got? Okay, you got 404 defined. Okay, now if you go back to my public bucket, okay, this is the bucket that is created to host my website. Go here, and if you try to do this, you got some other response, because this is publicly exposed data. Now you got some response, right? So, and this response, if you come here, okay, you're not seeing the response because there is no -v. Yeah, see this curl -v, it gives you some output, right? That means, so if you look at this, what is this? This is a 400 error. Okay, this is a 400 error. It is trying to connect to this and it didn't happen and it is reporting an error. Now, if you try to look at this, since it is a public bucket, you are getting some good response. So these 400 responses, keep on, you'll get, keep on, you'll get, keep on, you'll get, keep on, you'll get forever. So that means if some bad actor tries to know your bucket name, though your bucket has nothing, it's going to charge you like hell. Okay, that means if you create a bucket, though it is empty, and if someone, and if it is public, and if someone tries to guess your bucket name, and if they keep on access it, even 400 requests are charged by AWS. Okay, so I mean, this might sound little tricky, but this is a recent incident. That's the reason I was saying this to read you. Funny incident. Okay, I keep on reading articles, so I keep on share things. Okay. Oh yeah. Again, it is something out of nowhere it came up, but I don't want my infrastructure to be organized here. Instead, I want to say the infrastructure should be organized elsewhere. Okay, how can I deal that? So let me try to destroy auto approve. So let it destroy. Now I also don't want my infrastructure to be created here. So what I want to do is I would like to go with, this is called as a local state. Whatever we have used is a local state. Now I want to go into the remote state. So let me go with that. Okay. Okay. So remote state. Resource. Again, this is a null resource, by the way. Why did I create this? Main file. Okay, so I just want to create a null resource. Okay, again, it's just a dummy resource. Now, provider is AWS. Now, I just want to say Terraform state file. Okay, I want to create this infrastructure on AWS S3. So you need to mention this. Okay. You're telling I don't want my state to be local. Instead, I want this to be here. Okay, so Terraform backend is S3. If you're using Google, you use something else. And what is the name of the bucket? So in our case, the name of the bucket created by us is this. Where is B58-S30-02-SEP-2024? Done. And what is the path to the key? Okay, so I just want to say dev slash terraform.tf state. Done. And the region, it's your choice. You can either keep it or not. Okay, so in my case, I'm using US East 1. You just need to mention it. All right, now you try to push the code. Now cd to gp 10. Now see this ls-ltr. Okay, now if you come here inside this bucket also, there are no objects. Now if you try to make a Terraform init, see what will happen. It initialized the null resource that we have created. Let's wait. And then Terraform plan, just try to apply it. Okay, though it is a nothing, but just want to simulate the behavior for you. Okay, if you come this, okay, it has created the resource. Okay, though the resource is null, But if you come here and if you try to look at this, you won't be seeing the state file here. But if you try to come here and apply this, it says there are no changes. How does it come to know there are no changes? Because you told the provider, you told, I want the state file to be remote, and that too on the top of the S3 bucket whose name is B58-T-F-State-08. Okay, where can I find that? And you can see there are no changes. Now, where is it created? Do a refresh. Can you see this? So I told my object should be created inside a folder called as a dev, whose name should be terraform.tfstate. If you come here and if you try to access it, you can see terraform.tfstate. All right. So yeah. And I want to make some changes. Okay. Like what is the name? And I would like to create one more null resource. See, right now you come here and if you try to see this, okay, click on this object versions. There is only one version, right? Now, if you come here and I would like to create one more null resource whose name is, okay, bar. Push it, do a GP, and you will see obviously one more resource will be created, which is a new object. So obviously there are some changes in the state file, so it ends up creating one more version. Let me try to show you that. Okay, so there is a change in the state file. You come here and try to refresh it. You should be able to see one more version. Can you see this? Now I would like to create one more version whose name is bar or foo. Okay, and if you come this and try to refresh, you should see one more object. Okay, if you want to go back to the previous version, yes, you can always do that. Okay, actions. Okay, you can, if you want to go back to the previous version, you can mention, for example, you want to delete this object, you can delete that. Okay, so for example, if something got messed up and if you want to scroll down back, you can delete the old version or the latest version, which moves back to the previous version. All right, your data is safe all the time. All right. Any other questions? Okay, clear? But if you are maintaining multiple versions, like the same expense project, okay, I want to be dealt for, okay, so keep in mind the infra code that you're designing should be multi-environment. Okay, should be dry. Okay, it's already dry, but you need to write the code in such a way that it should work both for prod. Okay, in our case, okay, we create prod and dev. Okay, I don't want to maintain multiple infrastructures. Okay, the same code should work. In future, if someone says I want to create a QA environment, the same code with just one environment variable should be able to create. Okay, how can we deal that? All right. Any questions? Okay. Okay, so we'll organize the state in a very different way. Trust me, the way that I'm going to teach, you won't get anywhere in the internet mostly. Okay, these options are quite less used, but I have organized these things without the need of Terraform, Enterprise Cloud, and I handle the projects at scale. Okay, this is I mean, it's a choice by the way, but my way of dealing is somewhat little different. Okay, so let me try to show you that. Okay, Copy this. Multi-environment. Now here, how I am going to release, I should need both dev and prod. Let's assume. I can say env-dev env prod. Now here, all the environment variables that are related to the state, main.tfrs and all the state.tfrs. Okay. The main.tfrs env is equal to dev. And here the prod done. And here I'm not going to write anything. Okay, I'll just keep it empty. Okay, I'm just gonna keep it empty. Now in the state file, I'll just go here and I'll say here, I'll just say prod. Okay, here I'll just say prod and here I'll just say dev. Okay, done. Now, since I have used a variable, so just go here and try to say, what else do I need to say? Main.tf. What else I can say? Yeah, that's it. So that's it. Now I try to push the code. Now, since your data related to the backend is elsewhere, now you need to do something else. Okay. Okay. So Terraform init -- help. Now you're going to tell your backend information is somewhere else. So there is an option called as a backend config. You can mention configuration that to be merged with what is there in the configuration file backend. So here, if you look at this, whatever the information that has to be merged within this block backend, okay, can be placed inside this. Okay, this can be either a path to a HCL file or a key value pair or anything. Okay, I'm going to use backend config. If I want to create the information related to dev, I'll say env-dev. Okay, env-dev state.tfrs. Now you also need to say the same when you make a plan. It's not just hyphen, I think it's hyphen backend. Now when you run this, dev infrastructure will be created. Let's wait. Now Init is going to download all the needed plugins, and it is also going to, okay, initialize the backend modules, and it also going to download all the plugins that are mentioned. It is going to initialize your code child module, and it's also going to initialize your backend module. And it says it's not hyphen, it's hyphen hyphen. Obviously, I know the reason. It's not just hyphen, it's hyphen hyphen backend. Terraform Init is going to download all the needed plugins. It is going to initialize your root module, and it is also going to initialize your backend module. Okay, it says backend hyphen config. Why? Terraform init. Backend config is equal to env hyphen dev. Okay. Here, while during apply, I missed this. Okay, doing it. Done. Now when you want to create the infrastructure for the prod, you just supply the prod state file. When you want to create the infrastructure for the dev, you'll just supply the dev. But why it is paying why one only? Hyphen, even hyphen backend. What happened here? Okay. Maybe I need to supply it at the end. Okay, let's run one by one. Okay, no rush. Let me see whether I can run this or not. Terraform init is successfully completed. Okay, done. Now let's try to run the Terraform vars. Okay. Now Terraform plan. Okay. Oh, you don't need it. Okay. All right. Terraform plan. You initialized it by the backend provider, right? Now you're making a plan. Perfect. Now Terraform apply -auto -approve. Okay. Uh, Now it has created the infrastructure, right? Now what I want to do. Now let's try to change the name of the resources. Okay. Sample, simple, dimple. Okay. Okay, done. Now, if you try to apply it, see what will happen. It's going to create. Okay, it's going to destroy and recreate the old resources. That's right. Can you see this? Now, if you want to create the infrastructure for the prod, all you need to do is you just need to run this, but it will fail. I know the reason why. The reason for this is, okay, all the providers that you are downloading are going to be saved on this. So whenever you're dealing, since this is a local machine, you need to delete this file all the time. But when you're doing it from the UI, it's going to be everything on a brand new folder all the time, so you don't encounter this. So rm-rf.terraform, it's going to have all the plugins and the cache related to the old run. Since we are switching the environments, delete that. Okay, now you try to run it for the prod, it's going to create. Okay, so prod dev state.tfs, it's not there. env-prod, it's main. Though we are not using it, but I'm just saying it, main.tfs, state.tfs. Done. Could not be read. How come? Oh, prod data. Okay, env-dev, dev prod. Okay, one more minute. Here for a minute. env-dev. All right. Now it's env-prod, right? Now I'm going to delete the rm-rf. Now using this concept, with a single code, single set of code, and with a single set of bucket information. By supplying two set of bucket information, you can create, okay, multiple set of infrastructure. env-dev, env-prod. Okay, now you can apply, and it's going to create the production infrastructure. This is the structure that we are going to follow. Okay, can you see this? This way, you write the same code, you supply different set of variables for the environment, and keep the bucket open. Okay, don't supply the bucket configuration. We'll supply the bucket configuration by using the backend config. Okay, this way we can create multiple environments just with supplying multiple variables. All right, clear? Any questions? Any other questions, anyone? Okay, so from tomorrow, how are we going to write the Terraform infrastructure is? This is the standard that we are going to take. So ensure you understand this. Terraform modules for multiple projects. Okay, so what are we going to do is whatever the module, see, if you are working for 3 projects, it doesn't make sense to write the modules 3 times for 3 different modules, right? So typically in the organizations, how we do this, okay, you might be working for 2 to 3 projects in the same company, right? Legally. So what you can do is in the Git, you are going to create a repository, module A, all the information that is related, you're going to host it here, module A. Okay. Module A, module B, and module C. Now, whoever the project that they want to use, they can use, okay, for example, project payment, project cart. Let's say there are different projects and project catalog. Anyone, they can use these modules. All these guys can use any of the modules. Okay, but this is project. Okay? All these guys can use this project. So we'll extensively use these modules. Okay, so we are going to write the infrastructure in, okay, main module in one folder and backend module in a separate folder. Okay, so how are we going to create is for this project, we'll create 2 modules, expense Terraform. And the information needed to the backend module, we'll just create another folder whose name is, let's say TF module, TF module. Maybe we can also say TF module or something, anything. Not TF module expense. Okay, so expense Terraform. So this is for our project, and what are the modules that we need? We are going to create it here. Okay, this will be the root, and this will be the backend module. Okay, backend or child module, anything is fine. So earlier they used to call it as a backend, now they're calling it as a child, but anything. If you are talking to a person who know Terraform, he should understand. Okay. All right. That's it. I clocked 10 minutes extra. That's it. Please practice them. Okay. And these are very much important, which are widely used. That's it. That's for today, guys. Thank you. Any questions? Any questions, anyone? Any questions? Yeah, today is a fine day. We decided not to go with the session and we end up talking. It's a very good way. Any questions? Ambit, Arun, Girish, Harish, Mohini, Monica, Rachit, Sailaja, Shrideep, Vikram.
No.
Hi. Go ahead, Arun. Any questions, anyone? Questions. Guys, please practice them. Okay, we are going to apply all these concepts tomorrow. That's it. That's for today. And we're going to meet tomorrow in the session. Thank you. Signing off.